Hi students, in this video we're going to discuss about relations. Mainly I'll just try to cover all the important definitions from relations with the small examples. So first, before going to discuss about relations, you should know about Cartesian product of two sets. Means here, if you take any two sets, like for example A is equals to some A comma B comma C, and B is equals to some 1 comma 2. Like if you just do the mapping and all, like you can simply write like A is here and B is here, and A, B, C and 1 comma 2. Like how many mappings we can do, that is what we're going to discuss here. Like A comma 1 we can do the first one, A and 1, right? Then B, you can go with the same with the B and 1, right? Next you can go similarly with C and 1, same with A comma 2 and B comma 2, right? And C comma 2. So this is called as Cartesian product of two sets. Like A, this is represented by A cross B. So if you take A cross B, like you can see the definition here, the Cartesian product of A cross B is a set of all order pairs of the form A comma B, where the first entry comes from set A and second comes from set B. Right? It's like A and B. Simply A cross B is equals to A mapping with 1, B mapping with 1, C mapping with 1. Then similarly A with 2, B with 2 and C with 2. In that way we can just write that is known as a Cartesian product of two sets. So now what is the relation? Now relation can be any subset or itself of A cross B. If you take any relation, like simply if you take A, B, C and 1, 2, so A mapping with only 2, that is one relation. B mapping with 1, that is one relation. Whatever it is, like if it is a subset or equals to the Cartesian product of two sets, that is called as a relation. Let mean like there will be a relation between A and B now. A and B. So like for example here A is mapping A is mapping to B, right? So there will be some relation. A is like input and B is like output. Like for example if I say x plus y is equals to 2, then y is equals to what, 2 minus x. Now is the relation between x and y is this. That is what we are going to discuss here. Like for example if I write something like 1 comma 2 is the input here. Now what will be relation? If you substitute 1 here, output is 1, and if you substitute 2 here, it will be 0. So 1 to 1 you are getting and 2 to 0 you are getting. That is one relation. Like that we are going to discuss about relation, right? Now, yeah, that is a definition. Like as I mentioned, let A and B be two sets, then relation from A to B is a subset of A cross B. That is what I just discussed. Now, like if you have two sets, like one is having like 1 comma 2 for example, and B is having x comma y as the other set, then the number of relations. Like what I mentioned, first of all, if you write A cross B will be what, 1 comma x, 1 comma y, next 2 comma x and 2 comma y, right? You can see that number of elements in A cross B, if you can clearly see that number of elements in A cross B is what, n of A into n of B, right? N of A into n of B, clearly, because here the two elements, here also two elements, totally you can see 4 elements. Now sir, what about number of relations, sir? As I mentioned, relation is a subset. If you recall in sets you discussed, like you learned about subsets now. So what are the number of subsets? Like 2 power number of elements in the set that you're talking about. Here the set is what, A cross B. So simply here if you write 2 power 4, there is going to be 16 relations you are going to get. So whenever you have A cross B, if you want to find out number of relations from A to B, you can use the formula. This you can see that if n of A is m and n of B is n, then the number of relations defined from set A to set B are what, 2 power m into n, right? So like that we can discuss the relation, the number of relations from set A to set B, right? Sir, what is the domain and range of relations? Domain and range, like, so domain is the input and range is the output. Just now we discussed what in Cartesian product, like if you take A is some x comma y comma z and B is the another set some 1 comma 2, and if you write the relation is from A cross B. right? That means you are going to get your 6 elements, like because x comma 1, y comma 1, z comma 1, and x comma 2, y comma 2, and z comma 2. Now, so what is the relations or subset of this? Now, if I write the same relation, like for example, relation R is equals to, I wrote any subset of this, let us say x comma 1, y comma 1, and z comma 2 I wrote. Is this a relation or not? Definitely yes, because it is subset of A cross B. Sir, now what is the domain of this, sir? And what is the range of this, sir? Now domain is the input. So what is the input here? You can see that the first element is always input. So here x, y, z is our domain. And what is the reason of output? So output is what on a 1, 1, 2. So we'll simply write only one time. One is only we have to write one time because we know that. So definitely the element can't be repeated in a set. Right, like that we can discuss. You can see the definition here. Let R be a relation from set A to set B. Then the set of all first components or coordinates of the order pairs belonging to capital R is called domain. First components are coordinates. First components. You can see that. And while the set of all second components are coordinates are called as a range. That is what we discussed here. Right? Next. Inverse relation. Simple. For example, just now we wrote R is equals to some x comma 1 and y comma 1 and z comma 2 something I wrote. Na? Now for example, if R inverse if I want to write, then what I can write in a reverse. Reverse. Then it will be what on a 1 comma x, right? 1 comma y and 2 comma z. And you can see that just now we discussed about domain and range. Na? So domain of R, if you see, domain is what? X, Y, Z. And now that is equals to what? Range of R inverse. You can see that here, right? Similarly, if you look about the domain of R inverse is what on a 1, 1, 2. That means 1, 2. That is range of R, right? So that is the relation you have. So that means if A comma B belongs to R, A comma B belongs to R, then B comma B will be belongs to R inverse or reverse. Anything. Simple definition of inverse relation, right? Next, look at a question here. Just now whatever we discussed, based on that we can do a question here. Let capital A be the set of first 10 natural numbers and let R be a relation on A defined by x comma y belongs to if and only if x plus 2y equals to 10, right? So x comma y where x belongs to A and y also belongs to A. So they given that A is set of first 10 natural numbers. So let us write first A. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. They clearly given that R is a relation on A. That means R is subset R equals to A cross A. Because they clearly given R relation on A only, not B. Like if it is the given from A to B, then we can write A cross B. So here only they given first set. So we have to only one set they given. So only on that only we can discuss relation. Then how many elements I can take in A cross A? There are definitely 10 into 100 elements I can take. And how many subsets we can form on a 2 power 100. So, but we are not going to write everything here. So, whatever we need, that only we can discuss here. So, that's the reason they are given that. See, you can see that the relation they given is some equation. So, they clearly given x plus 2y is equals to 10. So, from this we need to find x comma y where x is belongs to A and y is also belongs to A only. That means you should get x and y elements in this A only. So what I will do is, here I will write 2y is equals to 10 minus x. Then y is equals to what, Nana? 10 minus x by, right. So what I can get? So definitely 10 minus x supposed to be what? An even number. Then only we can get a y, because x comma y both are natural numbers. They clearly given here x and y belongs to A, where A is set of first 10 natural numbers. So what values I can take in place of x? I can't take 1. Can I take 1? No, because 10 minus 1 is 9, 9 by 2, which is not a natural number. I can take 2. Next, I can take 4, I can take 6, I can take 8, and I can take 10, but 10 minus 10 is 0. 0 by 2 is 0, which is not a natural number. So if I take 2, 4, 6, 8. So if I take 2 is the input, then what is the output, Nana? 10 minus 2 is 8, 8 by 2 is 4. If I take 4 is the input, 10 minus 4, 6, 6 by 2 is 3. Next, if I take 6 is the input, so 4 I will get, which is 2. If I take 8 is the input, then I'll get 2 by 2, which is 1. So this is the relation we have. R is equals to, right? This is the relation we have. Now what is the question? Express R. This is R. Then R inverse is going to be definitely 4 comma 2, 3 comma 4, 2 comma 6, 1 comma 8. This is R inverse, right, students? So now domain of R and R inverse. Domain of R is 2, 4, 6, 8. That already we wrote here. This is domain of R. And the range, domain of R inverse is what, on 1, 2, 3, 4. 1, 2, 3, 4. So this is the domain of R, and this is domain of R inverse. And domain of R is what? Range of R inverse. And domain of R inverse is range of R. Like that we can discuss. Simple. Right, students? Hope it's clear to you. Okay. Next. There are like few more important types of relations are there. There, Nana. So which is void and empty. We know that like definitely when you take subset, there is a chance of getting empty set also. That empty set, whatever the empty relation that you're taking, that is known as a void relation, which is also known as empty relation. Right? Now here let A be a set. So there's a relation called the void or empty relation. So it is a null set. Universal. Universal means like ultimate, the final thing. You can see the previous example where you have A is equals to 10 natural numbers. So where you have A is equals to 10 natural numbers. So if you write A cross A on that set, that is a universal Cartesian product. That is a universal relation only, because itself also it is a relation. Because like for example, simply I will take for your example A is equals to 1, 2, 3. I will take Nana. So what will be A cross A? There will be like almost 9 elements. So 1 comma 1, 1 comma 2, 1 comma 3. Next 2 comma 1, 2 comma 2, and 2 comma 3. Next we'll get 3 comma 1, 3 comma 2, and 3 comma 3. So all these are like elements of A cross A. Now this is always a relation, right? So that relation is called as a universal relation, because this is the final thing. This is the maximum that we can get. All other relations are definitely minimum. You may get only one element, because if you take at least one element of that is a relation. No element also relation, because we have just now we discussed empty relation. 2 elements, 3 elements, 4 elements, like that we can take. So what is the ultimate, like what is the maximum relation that we can get is this, right? Next, identity relation. Let A be a set, then relation IA, sorry, there is a typo. It's supposed to be like this. Identity relation on A is called identity relation on A. In other words, IA is every element of A is related to itself only. That means, for example, 1 comma 2 comma 3 is there. The relation A is equals to 1 comma 2 comma 3. Then every element is related to itself only. That means 1 comma 1, 2 comma 2, 3 comma 3. Then this is called as what? An identity relation. Sir, now can I say that if 1 comma 1 and 2 comma 2 is identity relation? No, because whatever we have, like 3 is missing here. Then definitely, sir, can I say that 1 comma 1 and 2 comma 2 and 3 comma 3 or 1 comma 2, can I say it is identity relation? No, we can't say this is identity. This is only identity relation, because whatever the elements we have in A, all the elements are it should map out to itself. That is what they can. If every element of A is related to itself, every element of A. Okay. So here 3 is missing, and here you can see every element of A is relating itself, but 1 comma 2 is extra here. So 1 is not relating to itself. So that's the reason it is not an identity relation. Okay, students.